So in TD Volute, just like in TurboDesign 1, we start by loading the input file that was exported from TD Pre. And we can see the machine type has automatically been set as turbine. And if we proceed to the main dimensions, then these have already been pre-filled from the TD Pre file. And also the cross-section type has been set to asymmetric, and the shapes at the entry duct and the inlet have been set as elliptical external because this was specified in TD Pre. And the inlet tube settings are also preset to match those in TD Pre. Here we have the option to choose the type of inlet, such as tangential or radial, and we can go with a tangential inlet in this case. And then finally the most important part, which is the outlet boundary conditions, and this is specification of the radial and tangential velocity components along with the total pressure and temperature of the working fluid coming out of the volute into the nozzle. So we can specify a constant value throughout the circumference, or we can specify a profile as well. And in this case, we can go with a constant value that's been taken from the TD Pre report for all the different variables. So next we can run the calculation, which runs a 2D inverse design code to give us the optimum area distribution for the given volute outlet flow profile. And then in the post tab, we have a 3D view of the volute that we generated. As well as some plots such as the velocity vectors and the cross-section area variation along the circumference, which is clearly unique and non-linear. And finally, there are also some useful performance parameters of interest, such as the total pressure loss estimate and some other geometry parameters as well. And once we have the volute design, it is possible to directly export a solid IGS model of the same for a stage CFD analysis.